All right. Are you there, Lasse? Hello? Hello.
Hey Dave.
All right. Nice. We're live. So I thought this would be a great opportunity to do a little sneak preview, as you suggested, as a live
Yes.
hangout on air, so people can see what we've got.
Yes, right.
So
So we originally started because I wanted to show you how to glue one point to another coordinate. But the sneak preview is actually more about how to scale the skeleton, and just it's more the sneak preview for the wide or narrow fonts, or maybe for the small caps creation feature, whatever.
yeah.
The problem is that what I do is scaling the skeleton, but what I don't do is scaling the skeleton using CPS parameters. So that's why it's a sneak preview. But first I show you. I start my screen share, and this is the result we are going to have. But what I did is I already commented out like the important part of the CPS that I created, and so let me just start to create the original version without the glued point. This is Metapolator export. Where is it? There. I forgot. Oh, maybe it's here. It's Ralph improved. Okay. Ralph. I always have some strange names for, because it's like improved to what's the name? It's Ralph, I think. Yeah. I think it's Ralph. To Ralph. So this exported some already loaded file, and now I can reload it here. It should change, actually. Show me. Did not change. So now I'm really concerned. Not really concerned. Maybe this was not called Ralph. Oh, I made a typo.
That's all right.
So this is the unfortunate case when scaling the skeleton, that this part of the outline does not end up where it belongs.
Mm-hmm.
So I was smart and turned my editor off. This is the crucial part. Or maybe everything of this is the crucial part. But this is the whole master I created. In here we can't see the scaling of the skeleton because this one is not done at the moment with CPS. But this is the part that glues it. Before I explain what happens, I just run this command again. Ah, here's the typo, you can see it. This did not work. Ah, I have to remove the old instance first. So, just first remove. This should
You've got to do .ufo.
You're right. Very good.
Very programming.
So this worked. Now it's glued.
Look at that.
You've seen that. So this is what you meant. This is probably not working yet. This is actually working already. By using this rule, actually. This is the key of the rule. this dictionary rule makes available the x coordinate of the I just can read it out. It's glyph A, the first, index 0 is the first pen stroke, index 2 is the third point, and from the third point, one point in CPS currently consists of a left point, a center point, and a right point. Left point is the left outline point, center point is the skeleton point. So the left on-curve point, one left, center, or right point consists of incoming control point, on-curve point, outgoing control point. This is the on-curve point, and this is the x value, and we reference it as x-align. And then I can just use it in a normal CPS rule as the name x-align. This comma is the vector creation operator. So this is the x value of the vector. This is the y value, which is the original skeleton y value of this point. We move around currently the center point of the second pen stroke, fourth point, the center point. We can count the points from here. This is the first, second, third, fourth point. So, and the fourth point has the index 3 because we start counting with 0 at 0. We move the center point first to the x position of that reference point, and to the y position it had originally, because the parent skeleton on curve point y position is the position that center point has usually. This is referenced. This is declared in another in the default CPS file here. We say every on curve point has parent and skeleton on. This is a vector. This is the normal rule, and we override it here. And then we subtract the x offset of the left contour point of this point, which we need to otherwise I can show you. If we don't do it, we end up with the skeleton point exactly on the first pen stroke contour. If I remove this one, this is like exactly in the center.
Clever stuff.
So we need this one to like make the movement correct, and we only subtract the x coordinate, and the y coordinate is 0. So we subtract 0 of the y coordinate because the height is correct at the moment.
Yeah.
So this works, and the other thing I can shortly show is how to. Where are we? How the come on, font fortress a little bit.
Control F to fit.
Control F. Okay, right. Let's make it like that. The other thing is, I save this, is the sneak preview of scaling contour, right?
Yeah.
Let us do this. Too many open files, can't tell you. So it's happening actually in the pen stroke point mum object. There is a getter. This is this one. There's a getter for the skeleton coordinates. Don't know if it will be like this forever, but it is like this now. And this is the hack actually. This is the old code. Just return this skeleton, just the object where the data is stored, and now the hack is I create a which file? The file is app lib models mom pen stroke point.js. You can see here.
Yep.
So This is the small hack to transform actually only the on-curve points of the skeleton, because the other ones we don't use. But we probably will have to scale them too, because now it only works good with horizontal and vertical, like extreme points. If something is like directed not 90-degree upwards or to the side, it's not working so good. But in this case, the example works very well, I think.
Okay.
So this is no transformation at all, or let's say just transformation
and
of one.
And that transform scale method, that's something which is part of
UFO.js.
UFO.js in general.
In UFO.js is like this code to do affine transformations.
Okay.
This is there's actually it's used for a transformation pen that can be used to rotate or scale or whatever outlines. But this is just the math for it. I think I will maybe rewrite it because it's not so well done at the moment. But it works. So this is the important point, I think. So let's run it again. Go here. This is the original A.
Mm-hmm.
And I make it keyboards like 0.7. I don't know if I can scale it forever. But so this is like now a narrow version of the A. You can see here something funny happening, but
if you press the grav key.
What key?
The grav, which may be next to the Z.
See. I don't know.
It's this key.
Can you? I don't get it. What?
Sorry. This key.
Oh, something's happening. I heard a blip. And then what happens then?
You'll get a better preview in Font Forward.
Ah. No.
I think it's your German key bindings.
Oh wait. Is there a menu entry for this one?
View, show.
This one, preview.
And then preview, yeah.
Nothing changed.
But it's on a hotkey. So you'll need to rebind the key, I think.
So, but now it's on previews. It's turned on and
it's control on graph. Yeah. So turn it off on the menu and then try and press control on graph.
I don't know. So now this is German. This is English.
It might be.
No.
Okay, I'm sorry.
It does not like me. But it should be accessible through this menu, not?
It's broken. Yeah, that's broken.
Preview changes nothing. Just adds a check.
Yeah. Let me. I'll file an issue for that.
Okay, whatever. So this is somehow condensed A, and I don't know what happens with 1.7. Just try it out. Ran through, and this is a very, very wide A, maybe too wide for any good use.
Okay, so back to the demo.
Yeah. The demo is. Do you want to see
I think that's
more?
complete, isn't it? Is there anything more? I guess so. Yeah, I guess that's the.
I mean, yeah. There's not much more to show, I think.
Okay.
Just
All right.
restore some better version. I'm here's an E2. It works with the E2. It works currently only with A and E.
And so as that's getting wider, the strokes are not being distorted. Is that right?
Yes.
So the stems are scaling as well because you're applying it to the whole glyph.
No, the stems are not scaling. It's only applied to the skeleton. The stems have the same width.
Okay. Right.
So maybe I can just maybe you can see it here better. Just so this is the same width, and the curves are calculated by the tension values we imported.
Right.
So this is what this hobby algorithm makes out of them.
Yeah. Okay. Okay. So what do you think the next steps are? Because I think that in terms of the primitives required to cover the concepts that Peter has described in his Zurich report, if we can do kind of point nailing or binding, and we have the affine transformations of the skeleton, and we can address points by class, which we've all demonstrated just now, then I think that's it, right? That's all the primitives.
No, not quite. I think we need the width feature, and this is like some work on the pen still. I think the pen is not good enough at the moment. So, for example, if I apply rotation or skewing or so, it does not work because the control directions do not adapt to this kind of transformation. So I'd like to see the pen to be able to react on this kind of transformation too.
Okay. And do you think that that's a job that we can hand off to another developer?
Maybe. The question is, yeah, I could, yeah, maybe, yeah, I could try to ask someone.
Because I think that at this point, I think at this point we have enough of the primitives that we can start to produce useful, utilities. By utility I mean a small demonstration of utility. Web application, because the workflow at the moment is, the same as Metapost. You go from text editor to command line compiler to font forge previewer, and this is the same as Metafont. So the fact that this is all running in a browser environment, all the calculation is being done in the browser environment, means that I think if we were to use JSBin and move the compilation and rendering to happen in browser and the text editing to happen in browser, JSBin provides a simple environment.
Yeah, I know that. Yeah.
It's free software, and so that would be a great kind of next step for the kind of developer augmentation which you've argued for on the G+.
Yeah, I looked a little bit into it. I would maybe take the editor JSBin uses for sake of the syntax highlighting and stuff like that. Use this with some magic to make the CPS a little bit more accessible. So you could enter a selector and would be presented only with the relevant rules for that selector. So you could say select glyph A. It would present you only with the rules for glyph A. So you don't have to scroll like through thousands of lines or so.
Yeah, I mean, I think that using code folding in the editor, that can allow you to compact a long file into a manageable way. And so there's a trade-off here between using off-the-shelf libraries and building something that's custom and perfect for usage. And I think that right now what we want to do is to avoid writing any new code as much as possible and use as much off the shelf as we can.
Yeah, but the selector story is kind of already built because we needed to select the rules that we apply anyways. So this is not so much of magic, you know.
Well, it's Monday evening, so I'm thinking about what can we do in 3 to 5 days.
Okay. Yeah. Okay, so 3 to 5 days you need a tech demo in red.
No, so the tech conference is in 2 weeks. But yeah, I think we're very close to having visual toys to people to play with on the metapolator.com homepage.
Yeah. Okay, I could think of handing off the improving the pen model as we have it right now to Ruben, for example, because I think he will do it definitely.
Yeah.
And maybe some optimization tasks he should at least think about, because this is definitely a task for him. And I could try to get this demo running, which would feature scaling, because for the other transformations we need the improved pen, and we need the improved pen for good weight handling, which is currently not in the. It's a very straightforward pen implementation, which does not understand something like width, but it's not so hard to build. So what I want to add, currently it's all offsets of coordinates from, let's say, the center point or something like that. And what I want to have is more like an angle and like a width for it, and the width would translate to the weight of the pen probably. And maybe with some more tricks we could say, okay, the horizontal weight or the vertical weight, which would be like killer feature, right?
Right. Okay. Well, yeah, I think that kind of thing is, yeah, I think that's the kind of thing that we've talked about as being like a Metapolator plugin, right?
Yes, but we have currently no good. Yeah, this thing. I'm not sure.
Or does that? Because it seems to me that if we design if UFO.js and Metapolator is designed in an extremely pluggable, extensible way, and we think of all of these things as being written as plugins, even though they'll be bundled as part of the core functionality, then we're getting close to that Emacs architecture where it's self-extensible.
Yeah, it's in the moment. It's that's right. It's like built in a very modular fashion, so a lot of things are like small modules that do very specific stuff, which is I think good. But I did let out like a real plugin specification and API. So this is one thing we should think about, how we could get it in, and until until then, we just keep on building small and
I like
specified
that.
modules.
And again, I think that Ruben's background is perfect for developing this kind of plugin API.
Okay.
So that's again something that we can hand off to him. And then since you're a kind of designer developer, I really think it's good for you to be focused on these things that involve the integration of the visual design with the software development.
Yeah. So yeah, it's okay for me. So I will yeah. So I will try to get Ruben running with the pen,
Okay.
with the plugins maybe, with CPS, with the IDE performance optimization. Because what I did is it's like the how would you it's called the naive implementation. So the one where you can see the most how it works, but which is not the optimized one.
Perfect.
Which is, I think, which is a perfect point to start optimizing, I think, because it's like pretty simple to read and
yeah, and absolutely. You just need to get something that's running, and then other computer scientists can step in and do the optimization, and you can move into that designer developer.
That's how I understood it as well.
Exactly. Yeah. That's perfect. That's perfect.
Okay.
Great. All right. Well, we'll stop the call here. And
okay, good.
It's been great to see a sneak preview of it, and I'm very happy to see this wrapping up and coming together in the next few weeks.
Okay, good. Cool.
All right. Great stuff.
Bye-bye.